Good afternoon, everyone. So I'm Thibault Usel, a bachelor student in information science at the Geneva Management College. And what we will present you here is the result of my internship at the Digital Humanities Unit at the University of Geneva concerning the use of linked open data for the horizontal integration of exhibition information. So this work has been carried out under the supervision of Dr. Nicola Carboni and Professor Béatrice Joyeux-Prunel, Chair of Digital Humanities and founder and director of the ArtClass project. So in this presentation, I will talk about the linked open data mapping and transformation of one of the databases produced by ArtClass project, Bazaar. So we will see why we transformed it in linked open data, how we did it, and what are the benefits of such an approach. First and foremost, what is Bazaar? So it's an open access and collaborative international global database of exhibition catalogs from the 19th century to the present day. It gives access to all the information mentioned in the catalogs, from the title and description of the artwork exhibited to the exhibitors concerned, their address of birth, death, and residencies when it's available. So Bazaar is not a static database, but a very alive one. New contributors from all over the world continue to add new catalogs, enriching its already generous collection. The aim of Bazaar is to showcase the decentralized panorama of its catalogs, providing the available sources. It also wants to move the focus that is often too centered on Europe and North America towards a more global perspective of the discipline. Such a database enables analysis and sharing of the data to the advantage of researcher and any interested institution. One of my internship major stakes was to make these exchanges easier, as the database was conceived before 2010 in PostGIS-SQL. And as every SQL database, it relies on its own schema and thus wasn't directly interoperable. In order to make it interoperable, we decided to convert Bazaar in linked open data RDF using the Sidox CRM ontology. And in the next slide, we would like to show you the potential of such technology for the study at scale of art history. So why linked open data? The RDF knowledge graph are an answer to the material limitation of the SQL databases. It allows us to move away from a taxonomical thinking and express the natural intricacies of historical data in a way that SQL database cannot. Graphs are extendable, whereas the structure of a relational database is fixed. Graphs are also tools for exploration, while SQL databases are tools for storing data according to a pre-thought or premeditated schema. Graphs have the dynamicity to adapt to the multiplicity of scenarios that cultural and historical data needs. For exhibition catalogs, this is quite important as the literary genre of the exhibition catalogs has evolved a lot since its invention in France in the 18th century. So while the 19th century catalogs were quite systematic with 2 or 3 very regular structure used across Europe and America, the post-50s catalog have taken diverse forms. Since the 60s, they often assume a narrative structure that cannot be easily integrated in the fixed schema of Bazaar, despite its conceptual effort to adapt the database model to any possible catalog they found. So to solve this problem, we decided to choose a graph database, and within the plethora of technological choices, we decided to use RDF as it is embedded in a network of interconnected, open accessible, and reusable resources. No unique resource can contain all the information in a domain. And interconnection between knowledge sources is a key to enrich historical information. The modularity of the linked data paradigm will benefit the project as the database information can be detailed, contextualized, and enlarged thanks to other linked data resources such as Wikidata, ULAN, and GeoNames. While our stance philosophically aligns with the linked data principles, there are also other advantages. The very first is the query language, Sparkle. SparkQL, it's a standard API that programmers can use to retrieve and download bulk data. Researchers can then take the data out and use them in R or in Python to do further processing, making complex queries and filter through Bazart in a way that it wasn't possible with the previous interface. The advantage of a graph is that we can also slice it up as much as we want to retrieve exactly the node and the relationship that are important for our research. So another advantage is the community. Zeitalter CRM is an active ontology and de facto standard for RDF in the heritage domain. Reusing such an ontology for Bazart means, first, to opening up to a large community of active users who do not need an extra knowledge about the ontology to access our resources. As you could see earlier in the slide, using SparkQL, we quickly retrieve and enrich Bazart data, creating ad hoc data visualization in a Python notebook with the result of our queries. But how did we achieve that in the first place, and how can someone else do it? Well, then everything starts with a model, and Zeitalter CRM is at the core of it all. So the data model has been developed using a bottom-up approach, where we use the data extract from Bazart database to guide our modeling choices in using Zeitalter CRM as our main guiding ontology. The semantic pattern were mainly developed thanks to linked art, an application profile of Zeitalter CRM, and the SARI, which is the Swiss Art Research Infrastructure reference models. It's a collection of ready-made Zeitalter CRM semantic pattern built up by George Brozaker and Nicola Carboni. What we present here is our conceptualization of the domain, a data model that can be adopted to share exhibition data using CRM. It is important to underline that the complete use of the data model we propose here is not mandatory to aggregate the data. The user RDF gives the possibility to each institution to keep using their own data model while still sharing the data with the rest of the community. Integration are possible using common entities of reference to external knowledge base, for example, Wikidata. Now let's focus on the model itself. What you see here on the slide is a global and simplified view of the model used in Bazart. It displays the most important entities described in the data. Those are the exhibition, their temporal and spatial dimension, the catalogs, which are the primary source of our information, and also the exposed artists and their work of art. Let's take a look at one example in more detail. So here, it's the International Surrealist Exhibition of 1936. As you see from the slide, it's our source, the catalog, that presents us with a series of artists and works of art. We datified the information in RDF and transformed them for a easy understanding into a graphical diagram that reflect our mapping choices and the resulting data in RDF. So this diagram represents only one of the work of art present in the exhibition. It's the Carnival of Harlequins. In the data, the artwork is linked with its author, Miro, with the International Surrealist Exhibition, that is the exhibition in which it was exposed, in London, the place where it was held, and also the time information and the corresponding catalog where it was documented. This set of relationships do allow us to frame each exhibition in space and time, enabling further diachronic, social, and spatial analysis. Each work of art is related as directly as possible to every important entity, so the catalog that documents it, and the exhibition in which it was exhibited, also the artist that made it. Here, the artist on this diagram, due to the space and the layout limitation of the slide, it seems to be a dead end, but many information can be explored and retrieved from this node. For example, the artist's birth and death, and also his nationality, affiliation to artist group or specific school. Thanks to the linked data framework, it's also possible to interconnect each artist to its corresponding Wikidata entity. As for the artist, the exhibition node in the diagram can be explored and refined further. As we see in this slide, the exhibition is directly linked to both to the catalog, which it represents, and also to the work of art that were present during the event. Here, I just select a basic set of information about an exhibition, such as its time and place. But however, more information can be explored. For instance, we can retrieve information about other characteristics of the exhibition itself, if it was traveling or not, or if it was public or private. Depending on the available data about an exhibition and the level of details one retains, it is possible to grow our knowledge graph larger or not. So a big benefit from using LOD, linked open data, is that enable us to explore the data. Here, let's imagine we are interested in other artwork that were also displayed at the same exhibition. So starting from the exhibition node, we can find all the information about other artwork, such as The Difficult Crossing. It's a painting made by Magritte in 1926. From here, we are also able to get useful information about this artist, whose node is also connected to Wikidata, and thus find complementary information such as his pseudonym, place of birth, or political affiliation. Same kind of research can also be done with the work of art to find information that is missing from the catalog, such as the year of creation. Here we can see that the date indicated in our catalog is not the same that Wikidata is indicating. Now, to speak about the analysis of the data, I will leave that to Nicola, who will present it to you.
Okay, thank you very much. I will start to share my screen. So the question is why we are doing all of this. So, which is a very fair question. It's a lot of work, and for sure there is a data sharing component which is extremely important. But maybe what's also important to underline is we are doing also for ourselves. We are doing for enriching our data, we are doing for analyzing our data, we are doing it to interconnect with other data sets and have at our disposal major need of analysis. And so just to give you an example of our use, I will present it just in very few minutes, how we are planning and actually using the Bazaar link data. So start to say that you're going to see this interface. For the one that are not familiar with it, is a so-called Jupyter notebook, is a computational document when we use Python to actually make some query. You may see here, as I scroll down, some SparkQL query, which they look scary, but this one is actually very simple. And what we do here is just to create this document to explore Bazaar. And we use this SparkQL endpoint not just for two main reasons. The very first is actually to explore our collection. In here, for example, we just make some query, a very easy one to retrieve all the artists that have exposed in Paris and retrieve their address. These are all information present in Bazaar. We can retrieve it very quickly. As you may see, what is the result of a SparkQL endpoint is, of course, a table, and we can then project on a map. And based on that, we can try to understand more the geography of the city in the art geography of the city. Therefore, this is just a basic to let you understand. The next step is, of course, trying to understand if some part of the artist, for example, the one that exposed the Salon des Indépendants, are coming from one specific part of the city in respect to the one that somehow exposed to more classical, a more academic venue. This is all possible thanks to, as you may see, a very quick and initial query. But coming back to the example of the International Surrealist exhibition of 36, we can actually search Bazaar for it. We can search for all the people that participate in the work of art, but not everything is in Bazaar. Knowledge is not in a unique spot. So what we do is actually use SparkQL to connect automatically to Wikidata. We have common identifier for artists. So we pass through that, we browse this linked open data cloud, and we retrieve for each of the artists that participate to this exhibition, the place of birth, the coordinate of the place of birth, and the country where they are from. And thanks to that, we can have an analysis, more detailed analysis, what are on the participant of the actual exhibition and where they come from in respect to each country or in respect to each city. As you may see, a lot come from France, and of course, if they come from France, they come from Paris. And we can then do more data analysis, such as projecting such coordinate in a map and analyze them in respect to who come from where exactly, such as Caldera in this case. But let's step up a bit. There is another possibility, which is the one of traversing multiple nodes. In this case, we are actually looking for exhibition of Ferdinand Hodler, a famous Swiss artist. And we start from Bazart. We start from making a query to Bazart in order to find all the exhibition about this artist. And what we get is actually a very few exhibition. And you may see here a graphical representation. And as you see, there are 4 exhibitions, 1 traveling one, and two that share a place, which is Berlin, and different work that have been exhibited. But still, the query gives us some results, gives some interesting results, but not many. We do not have, as you may see from the map, much stuff in it. So one of the things that we may want to try at this point is to go to this link Open Data Cloud and traverse it, try to find where other information that are related to the artist. And fortunately, the CCART, which is a biographical dictionary of a database of visual art that is produced by SIC ISEA, which is the Swiss Institute for Art Research. He has produced an RDF, an export of their data, which, however, do not connect with us, do not connect with Wikidata. They connect with the authority of the German National Library. But thanks to actually the power of SparkQL and the power of the link Open Data Cloud, we can traverse the graph, passing and to understand the matching between the German National Library and Wikidata, and then find common identifier. And I really underline this part because it's extremely important. This would give us power to actually, at the end, as we see in the query below, to unite these two research on the same query. We are searching on one side from all, on everything, all the exhibition of Hodler in Bazart, and on the other, on CCART, thanks to, as you may see, possibility to pass through Wikidata to find common identifier. The result is pretty good, I have to say. So in this case, we actually see that we retrieve more than 1,300 exhibitions, single exhibition, and that we can then see and actually project in a map. And as we may see already from a quick visualization, our possibility to understand the exhibition history of the artist has increased exponentially, is very large right now. And that's and if we just compare how was before versus now, this gives us the possibility to complement our data to enrich them in a way that is not possible without such technology. And I give the word back and the screen back mostly to Thibault for concluding the presentation.
Thank you. So I'm going to be brief. So here we can say that we have an endpoint, a Sparkle endpoint that will become public next spring. And it gives the possibility to researcher and institution to retrieve, use, and interconnect with our data. And we hope that to see more exhibitions becoming available in LOD. So it's important to give access to more data, but most importantly, to increase also the usability of our data. The interconnection with the link Open Data Cloud will give researchers the possibility to analyze exhibition at scale and prompting new investigation of the and study also. And moreover, this increases also the prominence of each institution collection, making it an integral part of the art historical network LOD. So we have also a few words has to be said about the time that is needed for putting up such project. So the necessary work to get your data in a compatible LOD format can be easily done, especially now that the schema and the mapping file are available on GitHub. Adapting its code on the database in a given for a given institution should be fast enough. And well, during this presentation, we provide you with an overview of the potential and benefit of applying linked open data to exhibition catalogs, making clear such type of work can be done, how it can be useful to enrich your own catalog, how it can improve the analysis of the collection, and how it can be helpful to a digital art historian and digital historian to do large-scale study. So thank you for your attention.